Okay, so we want to sketch a graph of this function, and in our notes, I wrote down some steps that I think might be kind of helpful here. So let's work within these steps as we work on our graph. So first step is it's not always the most, or this question is not always going to have a lot of variety to it, but I ask it because, again, I want to orient you towards calculus in the future. I want you to be thinking ahead to future classes. And this is a really important question to start off with that is not always considered. So identify the domain. Well, we are working with a polynomial, and that implies the domain as the set of all real numbers. This means the same thing as this. You can pick whichever you prefer, right? What that means is we can plug in whatever we want. There's no problems, right? If we apply the leading coefficient test, this is what we were working on in a previous question, right? This is our leading term. And so that means that we are even and positive. So we open up. Even, positive, right? So now what we want to do is we want to find the real zeros of the polynomial. And this will take a little bit of side work for us. So to find the real zeros, let's call this step 3, we take our function f of x is equal to 3x to the 4th minus 4x to the 3rd. And to find those real zeros, often what we do is we just set it equal to 0, right? We want to find the values that make this polynomial equal to 0. So we say, let's set it equal to 0, and let's find the value or values of x. Now, because this is degree 4, that means we could have as many as 4 unique zeros, right? Let's see what we get. So I'm going to point out that we have a common factor between these two x's, right? And that's x cubed. So I'm going to factor out our x cubed, and we're left with 3x minus 4 is equal to 0. We're going to apply what we call the zero product property right here, which means that we can set this x cubed equal to 0, or we can set 3x minus 4 equal to 0. Okay, the zero product property tells us that if we have one thing times another, usually just a times b equal to 0, then either that a value is 0 or that b value is 0. And in math, that or means both could also happen. Right? That's not restricted. Okay, so over here, if we take the cube root of everyone, so cube root this side, cube root of this side, we end up with x is equal to 0. Now, because it's a cube root, I do not need plus or minus, but this is one of our zeros, and pay attention to the fact that this was cubed. This has multiplicity 3, okay? Over here, we can say, let's add the 4s. We have 3x is equal to 4 and divide by 3, which means x is equal to 4/3. This has multiplicity 1, okay? So there's your 2 zeros. Those are helpful to us. We want to find the y-intercept. So part 4, the y-intercept is us, let me say y-intercept means set x equal to 0. So we're essentially finding f of 0. So that's going to be, and you can use either the factored form or the original. I tend to use the original. 3 times 0 to the 4th minus 4 times 0 cubed. Well, both of those had x's in them, right? So the result is just 0. So the y-intercept is 0, 0. And then just as a side note on this third one, these 2 zeros we found, these double as x-intercepts also, right? So we actually kind of double dip on that particular question. When it comes to step 5, so we've done 1 through 4, right? When it comes to step 5, I actually usually plot my points, what I have first, and then I kind of circle back around to, do I need additional points? What might those points be, so that I'm not just kind of guessing blindly. So let's set up a graph So let's plot what we already know. Okay, we already know what our domain is, right? That doesn't necessarily get graphed, at least not at this stage. We'll kind of represent that at the very end. We know that our left and our right sides do face up. Sometimes it's helpful to kind of sketch that in, but it definitely depends, especially I don't recommend using pen in math. Maybe if that's something you can erase and kind of clean up later, that's fine. We have a point at 0, 0, right? That's one of our zeros. It also doubles as our y-intercept over here. And then we have another one just over 1. So it would be 1 and 1/3, right? Those are your two zeros. So I can already kind of see that maybe I drew these a bit wide, right? So this is where it's helpful to plot additional points. How steep is this, right? How high does this go? I can kind of see that my interval is broken up according to these zeros. So we have this portion of our domain that goes on this side of our first zero. We have another kind of grouping of our interval in between. And then we have a third one after this 4/3 value. So if I were to pick a number from that first group on the left, well, those are negative x values, right? So maybe I'll try f of -1. So that gives us, our original function was 3x to the fourth, so -1 to the fourth, minus 4 times -1 to the third. So -1 to the fourth is just 1, so this is just 3. This is -1, so we get plus 4. Right, so this is a 1 and a -1, which gives us 7, right? So 1, 2, 3, 4, 5, 6, 7. So that gives us another point right here. And you can see that that improves the accuracy, right? My first sketch that I did off to the left was way too wide, okay? So we know our graph is going to come down through this point, and it will cross through this 0. I know it crosses through because it has an odd multiplicity, so it cuts through it. If it was even, it would bounce back up. Between 0 and 4/3, I think I'm going to plug in 1. I guess I should make my spacing a little more even. I put 1, 2 spaces out, so I would put -1 up here. Let me just scoot it in. That makes everything cleaner. So let me call this one and this -1. So I am a little more consistent. So this ordered pair is still here, and this crosses right here still. So a value between 0 and 1 that we could use, or 0 and 4/3 is 1. So let's find f of 1. 3 times 1 to the fourth minus 4 times 1 cubed is going to give us, this is still 1, so this is just 3. This is also 1 minus 4, -1. So it'd be down here. And so we would have another point right there. Okay, so there's a point there. And then we want something after that 4/3. So how about 2? How about f of 2? You could also set these up as an xy table or xf of x table. That would work just as well. So 3 times 2 to the fourth minus 4 times 2 cubed. 2 to the fourth is 16 minus 4 times 8. 3 times 16 is going to be 48 minus 32, which gives us 16, which is actually way above what I've got. Again, you can adjust if you're drawing this by hand because you can raise this up higher. So your other point here at 2 goes pretty far up there. I mean, I can even estimate like way up here, right? That's pretty far up, but it gives me a good idea. So I know my graph cuts down this way. I'm not the smoothest at drawing graphs on this tablet, so I apologize. It cuts through like this, and then it cuts up. Not quite as shaky, ideally. And it cuts through, and this cuts through. Okay? Always remember to put arrows on both sides. It's not quite as smooth as I would like it over here. Like I said, it's a bit hard to draw on this tablet, but we will do the best we can. Why we write in pencil, right? You can erase and you can fix. There we go. Okay, make sure it does look continuous. Again, also make sure it's smooth. I tried to make this look pretty smooth right here. You don't want any pointed edges. You want curved edges. That makes it a polynomial. Polynomials do not have sharp edges like this first part. All right.